Hi, this is Paul again. Welcome to part 4 of CubicWonder. Here in part 4, I'm going to show you some more things that you can do with these cubes. These 40 pieces in each cube could be described as fractals. Now I'd like to show you what I call cubic slicing. First, let's take a look at slicing in the 3 polar axes. This is quite obvious because we're down to the Chico cubes. And we showed this when we flipped through the family of cubes in part 3. But what I'd like to show now is that the Plato and Bucky sets may be sliced in different orientations. Okay, to show this, we'll just go to the cube outlines first. And let's look at the longest diagonal. The cubes may be sliced perpendicular to this diagonal. If you study closely, you will see that each slice is perfectly parallel. And the distance between each slice is the length of the diagonal of the face of a Chico cube. The slice also passes perfectly along the faces of each octahedron. We just show one diagonal at the present, but there are 4 diagonals, so you can slice in any direction. So it's amazing, this thing could go on to infinity. Okay, we can now see that we can slice along the longer diagonal of the cube, but what about the shorter diagonal? When I was working on this little toy, I thought about this. After putting a little bit of research into this, I found 2 ways of going about this. The first method is splitting the octapieces and the tetrapiece in 2 equal sizes. But because there are 6 different diagonal slices, you'd have to move the blocks around manually. Let's take a look at the octapiece and the tetrapiece split first. Now let's do the second method. We put the blocks together and then we'll split them in all the orientations. Notice each face of the yellow tetra has 6 different segments. Now look at the red matching face of the octapiece. It has 6 segments also. Now let's split the octapiece up first. We have 6 equal shaped fractals. Now let's take a look at the yellow tetrapiece. It has 6 segments on each face, and there are 4 faces, so that makes it 24 pieces. Let's take a look. They're all perfectly equal in shape and size. So now we'll do the same to all the pieces of the Chico and Chica cube. So we have 4 octapieces in each cube. That gives us 24 new octafractals. And we have 1 tetrapiece in the cube. That gives us 24 new tetrafractals. So we have 24 and 24 in each cube. So we have 384 piece Plato and the same for the Bucky. Wow. Let's check the slicing. The slicing is good, so I must have done something right. I'm going to give these fractals a thorough test, so I won't give them a name yet. Let's give them a thorough test. Okay, let's start with fractal test 1 first. Let's do a 4-sided pyramid using short diagonal slicing. It looks as if it's going to work out just fine. Look at the corner pieces. I was concerned about the corner pieces, but they look as if they work out just perfect. Now we're getting an iteration of fractals. It's going in reverse actually. This is a word I picked up on YouTube. Notice the colors are all perfectly arranged symmetrically and in perfect order. Now let's make fractal test 2. Let's use 64 cubes for this. I will show how to do some X, Y and Z slicing. These are the easy ones. This reveals how CubicWonder is interrelated, and see all the different types of cubes, and you can see that it just goes on for infinity. We'll sharpen the points on the ends by using the short diagonal slicing. So you can see that this works out fine. We have one final test. This is the long diagonal slicing. We don't really need these new fractals for this, but we'll use them anyway because you can see how they all are arranged. Okay, we'll start doing some long diagonal slicing. I think the long diagonal slicing produces the nicest shapes. Now notice the colouring of these different shapes. Notice the green and the yellow always comes out adjacent to the purple and the white. This trend seems to iterate from the very first 40-piece Chico Chica arrangement. The number of triangles will keep increasing, and the geometric order, color and balance will be of a perfect symmetry. I am calling this feature the Chico and Chica phenomena. I realize that in this fractal and geometry business you have to use Greek or Latin names that are really long and hard to spell. But I think the scholars might have used most of the good words, so I guess we'll have to stick with the Latin Chico and Chica. So we'll keep whittling down from this shape and see how far we can go. Now this is the truncated tetrahedron. Now we'll go a little bit further. Okay, now we're getting down to the yellow tetrahedron and the red octahedron. We'll keep on going, and look, we're getting really down to the very first fractals. Notice that the vertex of the little yellow fractal is dead center to the yellow tetra. Also look at the vertex of the little red fractal. That is the dead center of the red octahedron. So I'm going to show that little center in the Chico cube. I'll add some red vertices to the cubes and make a 32 cube array. Now take a look at all them vertices. I think it's a little bit easier when you use Chico and Chica cubes. Okay, let's size everything up for these new fractals. Let's check out how many slicing directions we have altogether. Okay, let's start with the red vector, showing the slicing for the x-axis. We have a green axis and we have a blue axis. This gives us 6 slicing directions. We have 4 cyan diagonals on the bottom, and we have 4 cyan diagonals on the top. These are long diagonals. Finally, we have 12 short diagonals. These are the yellow ones. So altogether we have 26 slicing directions. So I think we'll call these new fractals vector 26, V26 fractals. This has probably been hidden in sacred geometry for thousands of years. Maybe I've just blown some dust off it. It was probably sitting on top of Plato's dictionary. Maybe Bucky's been moving it around. Anyways, what you see in front of you can be iterated into something beautiful also. I think we are just scratching the surface what can be done with this orderly system. Okay, I'm going to call it a day. So this is Paul saying thank you very much for watching my video.